Good evening, all. So we'll start day 3 session, Infosys Coding Round Training. So 4th January question. Today we will try to solve question number 3 asked on 4th January. So let me share the screen. So in previous lecture, we solved question number 1. So if you have not attended previous session, so please go to my YouTube channel. Question number 1 solved video uploaded into my channel. So watch that video. You will get some idea how the easy level question will be asked in a Infosys examination. Jan 4th question number 1 we solved. Okay. So today we'll try to solve question number 3 which is difficulty level will be hard. So audio, is it clear? Okay then. Right. So question number 3 which was asked on 4th January 2026 examination, Infosys examination. Okay. So the question is find the total number of valid ways to arrange the sequence modulo 9982444353. Okay, so we need to arrange a sequence. Okay, so you are given a sequence. So that sequence you need to arrange in number of valid ways. Okay, so what is the valid way that will be given in test cases? Okay, so find total number of valid ways to arrange the sequence. Here sequence can be anything, a list or array or a string. Okay, so modulo followed by this number. Okay, so why this will be given? Generally this is a large prime number. Okay, so that means final answer you should return by modulo dividing with this number. Okay, so that it avoids integer overflow for large number of values. Okay, so for greater values it avoids integer overflow. Okay, so for that purpose generally this large prime number will be given for us. Okay, so no need to worry about this modulo 9982444353. Okay, so concentrate on arranging in number of valid ways given a sequence. Okay, so what is the input format for this question? Okay, so the first line contains an integer n denoting the number of ancient values inscribed on a golden tablets. Okay, so don't worry about the description and all those things. Okay, so here n indicates what? N indicates the number of values. Okay, then the next line contains an integer k denoting the number of moments where the power of the number increases. Okay, so the value of the number increases. Okay, so that is indicated by integer k. Okay, so the next line contains an integer k. This you should understand very carefully. Okay, so integer k indicates what? The number of moments where the power of the number increases. Okay, so how many times the number increases. Okay, so that is indicated by this k here. then each line I of the n subsequent lines, then you will have n subsequent lines where n is nothing but the number of values, okay, in the array. Okay, so this each line contains an integer describing a of I value. Okay, so that means n values will be given, those n values will be stored in the array A. Okay, so n subsequent lines denotes these values. Okay, this is the input format. That means your input contains three parts: n number of values, k how the number should increase, okay, in sequence, then followed by n subsequent values. Okay, so that denotes the numbers. Okay, so that is the numbers present in the sequence. Okay, so all those numbers form a sequence. Got it? Right. Now these are the constraints. N is between 1 to 5 into 10 to the power of 3. K is between 1 to n minus 1, and each number a of I is between 1 to n. Okay. So here you are given the test cases here. Okay, so the first test case is given input is 2, 1, 2, 2 given here. Okay, so this first line indicates what? N value. Okay, so there are two values in the array. K indicates what? So how the value should increase. Okay, so this is called accent. So how the value should increase. K value should increase. That means the number should increase by 1 here. Okay, so then the next two lines forms the values in the sequence here, array A. Okay, so 2 and 2 are the values present in this sequence. Okay, so what you need to do? What is the problem here? You need to find out the number of valid ways in which you can arrange this sequence. Okay, so satisfying this K, satisfying the constraint, this K constraint here. Okay, so K is what? K denotes the number of moments where the power of the number increases. How the number should increase in the sequence, that is given by K here. Okay, so the number should increase by 1. Okay, so generally this we call as a accent. Okay, so that means if you arrange the numbers from when you traverse the sequence from one number to the next number, each time the number of times in the sequence the value should increase, should be 1. Okay, in that way you need to arrange this sequence. All the elements you should arrange such that there is only one increment when you traverse from one number to another number. Okay, so it should increase only one time. The number should increase only one time. That way you should arrange the numbers in the sequence. That is indicated by K value here. Okay, so let us analyze the question here. Okay, so the question given n value 2 here, K value is 1, and A, the sequence is containing the values 2 and 2 here. Okay, so if you arrange 2 and 2 in any ways, you will get again 2 and 2 only. Okay, so that means when you move from first element to second element, is the value increasing? No, the value is not increasing here. Okay, so he says that at least one time the value should increase. At least one time the value should increase. Okay, for example, if the numbers are like this 2, 3. Okay, so 2, 3, then what is happening here? 2, when you move from one element to second element, it is increasing. Okay, so 2 is less than 3 here. Okay, so that means one time the values are increasing. You arranged the numbers in sequence such that the values are increasing one time. Okay, so this is called a valid arrangement of a sequence. Assume that given input. Okay, so if you assume that the given input is something like a 3 comma 2. Okay, then this is one valid arrangement. Got it? Okay, but in our case it is 2 and 2. Okay, so that means explanation it is given clearly. There is no valid arrangement since both the elements are equal. Okay, so this you should understand from test case 1. almost 50% of understanding of the problem you should get it. You should understand the problem at least 50% from test case 1. With that knowledge, if you proceed to test case 2, your understanding will increase. Got it? Now, let us move to test case 2. Okay, so test case 2 input is 3, 1, and the elements are, that means there are 3 elements in the sequence. Okay, so k is 1. So the sequence should increase 1 time. That way you should arrange the numbers. What are the numbers here? 3, 2, 1. Okay, so they are given here. Just see here. N is equal to 3, k value is 1. So what should be the output? Output should be the 4. Okay, so that means there are 4 ways in which you can arrange. 4 ways of arrangement is there. That is the meaning here. In 4 ways you can arrange these numbers. You can arrange these 3 numbers such that the numbers at least increase 1 time in the sequence. Okay, if you arrange the sequence, at least when you move from one number to another number, at least 1 time, only 1 time the number should increase. That way you should arrange these numbers. Okay, so let us first write down our input array here or sequence. So it is given as a 3, 2 and 1. 3, 2 and 1. Okay, so now you arrange these numbers such that when you move from one element to another element, at least 1 time the number should increase. Okay, so what you need to do? Let us start first. We'll start keeping the 1 in the first place. Okay, so then if you keep 2 in the second place, okay, so 1 is less than 2. 1 is less than 2. Okay, so it is increasing 1 time. Okay, but if you write 3 again here, again second time, when you go from 2 to 3, again one more time the number is increasing. 2 less than 3. Okay, the number is again increasing. So here what happened? 2 times. If you arrange the sequence in this way, so numbers are increasing okay, in the order. 2 times it is increasing, but k value is given only 1. K value is given 1. Okay, so that means you arrange the numbers such that the increase will be only 1 time. Okay, so that means you cannot say that this is not a valid sequence. Okay, so these kind of problems are examples for permutations, finding all permutations with the given conditions. It is best example for finding all permutations of a given arrangement here. Okay, so first let us try to find all the permutations for a given sequence. From that you can easily get the idea. Okay, if you can write all the permutations for the given sequence. Okay, so what is the number of elements here? The number of elements are 3 here. Okay, so if the number of elements are 3, how many ways you can arrange these? You can arrange the numbers in a 3 factorial ways. Okay, so 3 factorial is what? 3 factorial is a 6. Okay, so that means 6 ways you can arrange these numbers. Okay, so let us arrange these numbers in 6 ways. Okay, so first I keep the first number 1 in first place. Okay, then remaining 2 elements are I arrange here. Okay, so 2 and 3, this is one arrangement. Okay, then 1 I keep in the first place, then 3 I write first, then 2, this is one more arrangement. Okay, so then the second arrangement, 2 I keep in the first place. Okay, so then 1 followed by 3, this is another arrangement. Then 2 I keep in the first place, then 3 comma 1, this is another arrangement, permutation you can say here. Okay, so then next 3 I keep in the first place, 1 comma 2, this is one arrangement. Okay, so 3 I keep in the first place, then 2 comma 1. Okay, so these are all 6 permutations or arrangements in which these 3 numbers can be organized or arranged. Okay, so out of these 6 permutations, how many valid permutations are there satisfying this k is equal to 1? Okay, so that means at least 1 time number should increase. Okay, so let us find out. Okay, so we'll take one by one here. Okay, so first we'll take this first permutation here. Okay, so when you move from 1 to 2, it is increasing. 2 to 3, again increasing. That means 2 times increase is happening here. So that is, it is not a valid permutation. Okay, so now you can see here, when you move from 1 to 3, it is increasing. When you move from 3 to 2, it is not increasing. That means the increase is happening only one time. That means this is a valid permutation. Okay, so then 2 to 3, if you go, then it is not increasing. 1 to 3, it is increasing. Okay, so that means the increase is only one time, so it is again a valid permutation. Okay, so 2 to 3, when you go from 2 to 3, it is increasing. Okay, one time. 3 to 1, it is not increasing. That means only one time it is increasing. So this is again valid permutation. Okay, so k value is 1, so that's why only one time the number should increase. Okay, so 3 to 1, when you go from 3 to 1, it is increasing. Okay, 1 to 2, it is not increasing. That means the increase happened only one time. This is a valid permutation. Okay, so 3 to 2, if you go, it is increasing. 2 to 1, if you go, again increasing two times. So this is not a valid permutation. Okay, so total how many we got here? 1, 1, 2, 3 and 4. Okay, so 1, 2, 3, 4. So we got a 4 permutations. Okay, so you can look at these. See here, with exactly k is equal to 1 increasing pair. Okay, so there should be one increasing pair. The answer is 4. Output is 4. We got the same. And these are the rearrangements. So 1, 3, 2, we got the same. Then 2, 1, 3, 2, 1, 3, we got the same. Then 2, 3, 1, 2, 3, 1, we got. Then 3, 1, 2, 3, 1, 2, we got. Okay, so we also got the 4 arrangements. Got it? So this is how you should come up with the answer. From the given input, if you can derive the answer. Okay, so input to output mapping, if you can done manually on piece of paper. Okay, so then your level of understanding is 100% for the problem. Okay, so then easily you can convert the logic into code. Okay, so having known the solution for this test case, let us move to next test case, whether our understanding will be applied, our logic will be applicable to next test case or not. That you need to test. Okay, so let us go to test case 3 here. The input is 3, number of elements 3 here, n value is 3, k is equal to 2. Okay, so that indicates that there should be two increments or increases. Okay, so two pairs where the increase should happen. So what are the elements? 1, 2, 3. 1, 2, 3 are the elements here. Okay, so let us first take the array 1, 2, 3. Okay, so first arrange these numbers. Okay, so let us arrange these or find out all the permutations. Okay, so what are all permutations you will get here? The first one is 1, 2, 3. This is one permutation. You will get 1, then 3 here, 2 here. Okay, so then next arranging 2 first, then followed by 1, 3, then 2 followed by 3 comma 1. Okay, so then next 3 followed by 1 comma 2, then 3 followed by 2 comma 1. Okay, so these are all the 6 permutations you will get. Out of these 3, check out which satisfies k is equal to 2. Okay, so when you move from 1 to 2, it is increasing. 2 to 3, it is also increasing. Okay, so this is valid arrangement. So 1 to 3, it is increasing. 3 to 2, it is not increasing. That means increasing happening only once. So it is not a valid arrangement. 2 to 1, it is not increasing. 1 to 3, it is increasing. K value only one time it is happening. So this is also not a valid arrangement. 2 to 3 it is increasing. 3 to 1 not increasing. One time only, not a valid arrangement. 3 to 1 not increasing. 1 to 2 increasing, but it is not a valid arrangement. 3 to 2 not increasing. 2 to 1 also not increasing. This is not a valid arrangement. So how many we got? 1. So output is also 1. So we got the output 1. Okay, so when applied the same logic, okay, so we got this. Okay, then how to convert this logic into code? Okay, so that is a second important part. Okay, so what we need to do here? So first we need to take the array. Okay, so we need to take the array, then find out all the permutations of this array. Okay, so find out all the permutations of this array. Okay, sometimes what happens now? If your array contains duplicate elements, see from test case 1, you can know that it may contain duplicate elements. Okay, 2 and 3 contains distinct elements, but sometimes your array may contain or sequence may contain duplicate elements. Okay, so what happens when duplicate elements are there? Okay, so let us just write all the permutations. Okay, so let me take an example here. For example, if my sequence contains 1 1 2. Okay, so what are all permutations we will get here? Okay, so first permutation is 1 1 2. Okay, that means this one I keep in the first place. Okay, so then 1 2 1. Okay, then I keep this one in the first place, then 1. Okay, so then remaining two elements I arrange like this 1 2. Okay, then 1 followed by 2 1 I get. Then I keep 2 in the first place, so 2 followed by 1 1. Then again 2 followed by 1 1 I get. Okay, so these are all 6 different arrangements I will get. Okay, so out of these 6 arrangements, you can look at, there are some duplicate arrangements here. Okay, so this and this, you can see here, these two are duplicates here. Okay, similarly these two are duplicates here. Okay, and these two are also duplicates here. Okay, so how many distinct are there? That means there are only 3 distinct permutations are there. Okay, so that you need to find out. Okay, so if your input sequence contains duplicate values, find out all distinct sequences or distinct arrangement. Okay, from those distinct arrangement, just you check out which how many arrangements satisfy our k value. Okay, so they give us the final answer. Okay, so this is how you should follow the logic. Okay, so a will be given, so what you need to do, you find out all the permutations. Okay, so from that remove duplicate permutations and get only duplicate permutations. Okay, so only distinct permutations you get. Out of distinct permutations, how many satisfy by following this k value. Okay, so they forms the output, real output. Okay, so this way you need to convert the logic into code. Okay, any doubts in this? Any doubts? Say yes or no. follow my Telegram link for more updates. Okay, so you can find my Telegram link in the chat. Similarly, in the description, I have given WhatsApp group link, Infosys training group link. You can join that group also, so that you will get all the updates and previous question solutions. I'll just upload in the group. Okay, so you can get all such previous questions and their solutions. Right. So having known this logic, okay, so let us implement this logic, convert this logic into code. Okay. So what we do is we will open. So let me show the pre-written code for this question. Okay. So test case 2, and this is the pre-written code. Okay. So this code is given, and you need to understand the pre-written code also. Okay, so what is doing in the first step in main function is defining here. So here is reading the n value. Okay, so using the read line method, n indicates the number of elements in the sequence. Okay, so then k value is reading from the standard input. Okay, so then defined an array and reading the sequence elements into this list here. Okay, so a is a list, and storing these values. Okay, so in this these are the values, list values, a values is reading from the standard input. Okay, right. So then is calling a function called as calculate. Okay, n, k and a are passed as an argument. Okay, so now this is the function defined here. Okay, so you need to write code here. Okay, so this you cannot change this code. Okay, so this code is already pre-written code. Okay, so you cannot change, you can't make changes in this code. You are not allowed to make changes in this code. Okay, so only thing is you need to write the code at this part. That's it. So then if you run your code, automatically it reads n value, k value and a values, and tests against the all test cases. Got it? Okay, this is how the uh, editor, online editor will be for Infosys examination. Okay, so let us open IDLE in Python, and let us write the same code and execute. Okay, so we'll complete this function. Okay, so let us execute the code here. Okay, so let me open the IDLE. I'll open IDLE here. So here we need to write the code. Okay, so what we do is we'll pre-written code. Okay, so that pre-written code directly. Okay, so I typed that code. Okay, so pasted that pre-written code here. Okay, and this function we need to finish. Got it? Okay, so here we need to finish the code. Okay, so let us write the code here. Let us write the code. Okay, so you need to understand input format and output format. Okay, so here n indicates number of elements in the array, and k is how many times the increase should happen. Okay, so that is given as a k here. A is the sequence. Okay, now so as I said, what we need to do, we need to get all the permutations. Yes or no? Okay, so for that in Python, okay, so we have, if you are not allowed to enter in this part, okay, or at this part, okay, so if you are not allowed to include the uh, modules also, okay, so you can include those uh, modules inside the function, no problem. Okay, so for that in iter tools module, okay, so we have a package called, you import this package called as a permutations. Okay, so in Python, to find all the permutations, no need to write the logic, there is a package called as a permutations. Okay, so that permutations, import the permutations library here. Okay, so how you can find out permutations, I'll just uh, show you here. Okay, so there is a function called as a permutations, and pass the sequence as a argument. So this gives all the permutations, okay, so that you can collect in a variable. Okay, so then this returns a permutations object here. Okay, so it returns the permutations object here. You will get the permutations object here. For example, as we seen here, okay, so if your A is this one, if your A is 1, 2, 3, okay, if your A is 1, 2, 3, okay, so then permutations means it gives all these permutations, okay, so all the 6 permutations it returns. Okay, so now your P looks like this, okay, so your P looks like this. Okay, so P permutations, it is nothing but a list containing a sublist. Each sublist is a permutation of this one. Okay, so this is how you will get all the permutations. Okay, so sometimes we may have duplicate permutations, as we discussed here, like this duplicate permission, two times it is appearing here and here. Okay, so no need to process them two times, it is waste of a time. Okay, so you may get a TLE, time limit exceeded error you may get here. Okay, so that's why you need to get only the distinct permutations from this. Okay, so what you can do is to get the distinct permutations. Okay, so you can use the set data structure. Okay, so in Python we have set data structure. Okay, so we don't require all these permutations. Okay, so out of these permutations, okay, so what we do is we eliminate directly the duplicate values. So set data structure eliminates the duplicate elements, so directly you say that set of permutations of a, set of permutations of a. Okay, so this gives only the distinct permutations. Okay, so as we said, so it gives only the distinct permutations. So like this you will get only the distinct permutations, eliminating the duplicate ones. Okay, so that means now your P contains only the distinct permutations, like 1, 1, 2, this is one permutation. Okay, so then 1, 2, 1, I'm just taking an example here. Okay, so then 2, 1, 1, like this. So now there will be only three elements in this P object. Okay, so out of these three, now how many are satisfying the given condition K value, that gives the answer. That's it. Okay, so what you need to do, you need to traverse this P and check out whether each permutation satisfying this K value or not. If satisfied, then you go on count how many. Okay, so for that we require a count variable. Okay, so we'll take a count variable here. Okay, so then we go on counting them. Okay, so I'm just adding a variable called as a count, initialize it to 0. Okay, so then what we need to do, we need to traverse the P here. Okay, so P is nothing but the permutations. No, so we'll take a variable called as something like permutations. Okay, so that you can use the variable P here. Okay, so P for P in a permutations. Okay, so when you say for P in permutations, so what it returns? It returns each tuple. Okay, so you'll get each element. Each element, this will be stored as a tuple in this permutations variable. Okay, so in this perms variable, perms variable. Okay, so it will be stored as a tuple. Okay, so list of tuples will present. Okay, so from this what you will get is one by one object you will get in this. Okay, so first object you will get into this P. Okay, so like say for example your P, your P may be, okay, so it may be the first object. Okay, so what is the first object? 112. Okay, so that 112 will come to this P here. So your P may contain the first as a tuple it gets. Okay, so 112, the first element you will get into the P here. Okay, so now you got the first element. Then how to check whether this satisfies our condition or not? So what you need to do, you need to traverse from one element to another element and check whether the elements are in increasing order or not. That's how you should uh, check the condition. Okay, so for that you need to traverse these elements. Okay, so again you require one more for loop to traverse all the three elements in this tuple. Yes or no? Okay, so for that what we will do is we will take a variable called as a ascents. Okay, so ascents is equal to initialize it to 0. Okay, so we'll count how many ascents are happening, increments are happening here. Okay, so we run one more for loop on that tuple here. Okay, so for I in a range, then how many times we should, it is nothing but the length of this P. Okay, so length of P means it gives a 3 here. Okay, so when we say length of P, it gives the value as a 3 here. Okay, but in 112 how many times we should check increments is happening? When there are three elements, only two times we'll check whether increment is happening or not. Okay, so that means we should run a for loop only two times on this tuple. Okay, so then it should be length minus 1. Okay, so it should be length minus 1, length of P minus 1 times we should run the loop. Yes or no? Okay, right, so now I value will be starting from what is I value here? I value will be length of P is 3. 3 minus 1 is 2. That means it generates 0 and 1. Okay, so now I'll show how 1 1 2 will be stored. Okay, so it is 0 1 and 2. Okay, so this is a tuple. No, so the indices for these tuple values are like this: 0 index, 1 index and 2 index values. Okay, so now you compare index 0 and index 1 value, whether it is increasing or not. How do you know that it is increasing? For example, if the values are like this: 1 3 2. Okay, so how do you know that when you move from one element to another element, it is increasing? That means the value at index is, for example, if this is something like P. Okay, so this is your variable P here. Okay, so if P of 0, okay, so P of 0 is less than P of 1. Okay, so 0 and 1 you compare. Okay, so if the first element is less than this, you can say that the number is in increasing. Okay, so that's how you should. So then you can say how many times it is increasing, one time. So then you can just increment this ascents value. Ascents plus is equals to 1, you should say. Afterwards you should check, and again when you go from second element to third element, again if it is less than, it is increasing, one more time you should increase the ascent value, and finally you should check our ascent value whether is it equal to k or not. This is how you should decide whether this tuple satisfying our given condition or not. This way you should code. Got it? Okay, so the same thing now I'll write in the code. Okay, so first for I is in the range, so I value will be 0. Now I am checking p of 0 and p of 1 values. Okay, so if p of I, if p of I is less than p of I plus 1, p of I plus 1. Okay, so then we'll say that it is increasing. How? First time we are getting the increase, so ascents increment the ascents value. Ascents plus is equals to 1. Okay, so like this it repeats this for loop. Ascents plus is equal to 1 here. Okay, so in this case what happens, we'll try to find out. Okay, so in this case two examples I'll take here. Okay, so 1 1 2 I take. Okay, so 1 3 2 also I'll show the example. So first I value will be 0 here. I value will be 0. P of 0 less than P of I plus 1. For this case I am taking 0 less than I plus 1. No, so this is not executed. So again goes to the loop. I value becomes a 1 here. Okay, so that means first two elements it is not increasing. Then it checks the next two elements here. Okay, so then it checks P of I. So P of 1 less than P of 2. Yes. Okay, so then ascents plus is equal to 1. So your ascents value will become 1 here. So ascents is equal to 1 here. Okay, so if our KY is equal to 1, then ascents is satisfying this one. So then you can say it is a valid arrangement. Okay, so in this case what happens, we will see here. For example 1 3 2. Okay, so 1 less than 3. Yes, so then ascents value will increase here. Okay, so ascents value will become 1 here. Then when you go from second element to 3 less than 3 to 2. Okay, so 3 less than 2. No. Okay, so then ascents value is not increasing, so ascents becomes 1 here. So if k value is 1, this is also a valid arrangement. That's how for each tuple we need to check out this, and we need to find out how many. If it is a valid tuple, okay, so valid tuple, that means we got one valid tuple, then increment the count value. You can say count plus is equals to 1. Okay, so this we will arrange it right in the code. Okay, so like this the loop repeats for end of the tuple. For two pairs it repeats. Okay, so once you come out from the loop, that means it has compared and it has counted how many times increasing. This increase is happening in this tuple. Okay, so now you check whether your increase ascents. Okay, so ascents is equal to the given k value. Okay, if it is given, that means it is a valid arrangement. So then you count it as a one valid arrangement. Count plus is equals to 1, you can say. Okay, so this entire thing is inside the for loop. Okay, so this you should keep outside the for loop. After coming out, then you need to check whether it is a valid or a not. Okay, so you should be very careful, because when you uh, enter, okay, so the cursor may go inside the for loop. Okay, so you should be very careful. It should be outside the for loop, right? Okay, so we'll take one example, and whether this code satisfies our example or not. Okay, so what example we will take, let me just uh, clear this. I'll clear this everything, okay, so that I can show you one example how our code counts the number of valid arrangements here. Okay, so just we'll take one example. In a previous example, we have seen one such example, no? K value 2 and 1, 2, 3. Okay, so that we will consider here. Okay, so let us take our A containing 1, 2, 3. Okay, so K, two increments we required here. Okay, so now see here. So permutation set, it find out all the permutations. What the variable permutations contains? It contains all the permutations. Okay, so only distinct permutations. Okay, so then you will get all distinct permutations in this. Okay, so what are all distinct permutations you will get? 1. Okay, so 2, 3, it is a distinct permutation. Then 1, 3, 2, this is another distinct permutation. Okay, so this will be stored as a tuple. Okay, internally this will be stored as a tuple. Okay, so then 2 contains then 1, 3, this is another okay, so then 2, 3, 1, this is another permutation. Then 3, 1, 2, this is one more permutation. Then 3, 2, 1, this is another permutation. Okay, so this is how these permutations variable contains these 6 permutations. Okay, so then we'll take a k value, count value is equal to 0. Okay, so count value I'm taking as a 0. Now execute this for loop for p in permutations. Okay, so first element, one by one element will be retrieved into the p. So first I'm taking this p. Okay, so I'll show p value here itself. This is nothing but the p here. Okay, so ascents is equal to 0, so we'll keep ascents as a 0. Okay, now again I am running the loop on this p here. So for I in range, length of p minus 1 means p value length will be 3. 3 minus 1 means 2 times it repeats. So okay, so what are I values for this? I values will be 0 and 1 here. Then it checks p of 0 less than p of 1, 1 less than 2, yes. 1 less than 2, yes. Okay, so they are in increasing order. Then ascents is equal to 1, ascents will become 1 here. Okay, so then I value will be 1 here. So p of 1 less than p of 2, yes. Okay, so it is also in increasing order. Then ascents plus is equal to 1, ascents will become 2 here. Okay, so then come out from the loop. After coming out from the loop, okay, so this internal loop, no, so it should be at this place. Okay, so let me just enter inside the for loop. It should be exactly here. We have written outer loop, after outer loop. Okay, but after coming out from inner loop, that means after checking a tuple is valid arrangement or not. Okay, so that you are checking here. Okay, so then what you are doing here? So you are checking if ascents is equal to k. Ascents, what is k value? 2 here. Okay, so ascents is equal to k. Yes. Okay, so that means this is one valid arrangement. 1, 2, 3. 2 times it is increasing is happening here. Count will become 1 here. That means we got one such a arrangement. Okay, so then again it goes to outer for loop. Okay, so see here, this entire thing is inner for in outer for loop. Okay, so control goes here. Then p then gets the next value. So this time p will be, this is p now, your p here. Okay, so ascents will be 0. Again we should start from the first onward. So that's why again we'll make ascents value is equal to 0 here. Okay, so this we made as a 0. Then again run a inner for loop on this tuple here. For I in range, I value will be 0 first. So just check out p of 0 less than p of 1, yes. Okay, so then ascents will become 1 here. Okay, I value becomes 1. P of 1 less than 3 less than 2 are no. Okay, so this is not executed. Then come out from the loop. Ascents is equal to k a call. Okay, so it is not equal here. So that's why this is not a valid arrangement here. Okay, so again goes, so like this it repeats p for each of the tuple here. Now you can just check out here. So 2 less than 1, no. 1 less than 3, yes. So k value ascends becomes 1 equal to k na, no. So that's why this is also not a valid arrangement. Okay, so then go for this next one. 2 less than 3, yes. Okay, then 3 less than 1, no. Only one time happening. This is not a valid here. Okay, so then 3 less than 1, no. 1 less than 2, yes. One time is happening. So this is also not a valid here. Okay, so then 3 less than 2, no. Okay, 2 less than 1, no. So this is also not a valid arrangement. So then, so for this k value 2, okay, so 2 times increase should happen. So how many such arrangements are there? Only one arrangement is there. Then the output is 1 here. Okay, so that means finally where is that output? We are storing in a count here. Okay, so finally you should return that count value here. Okay, so after coming out from the outer loop, okay, so then what you need to do is you need to return the count value. But before returning the count value, you divide this with a modulo of a given number. What is the given prime number in the question? 9982. Okay, so double four 8244. Okay, so 353. This is the prime number given. Okay, right? I'm just formatting this. Got it? Okay, so just let me remove this everything. This is, let me quit this. Okay, got it. So let us save this program. Okay, so let me save on the desktop. Okay, so something like I just say one dot py, already one is there now. So one or something I store. Right. So let us run the code. Now it is waiting for the input. Okay, so all the test cases will test one by one. Okay, so let me go with first test case. Test case 1. Okay, so we'll take test case 1 and we'll pass as a input to our program. Okay, so now it is waiting here. Then I enter. So name K is not defined. Did you mean capital K? Okay, so just look at here. So there is some mistake in the code. Okay, so yeah, hopefully this in the given function definition it is given as capital K, but I typed small k here. Okay, so you change it to capital K. Okay, so save it again. Again you run the code. So again you enter the input here. Okay, so let me just show you where I am entering. In the command prompt I am entering the input. Okay, so you can just see here I am entering the input here. So previously I got error. So small k not defined, that is what the error I got. Now enter this, we will get as a 0. Okay, so output we got as a 0. Got it? Got the output 0. Okay, so let us run the code one more time. I'll run the code one more time so that you can see the output screen directly. Okay, I'm running the code one more time. Just look at the code. Okay, so let us run the code one more time and we'll pass second test case as a input. Okay, so this takes us to command prompt. Okay, so here we'll pass the second test case as input. In this case, we should get 4 different arrangements. 4 we should get. Okay, so I'm just entering input here. You can see 3 1 3 2 1 I'm entering. Okay, so then you can see 4 here. Okay, so that means there are 4 arrangements as we discussed or given in the problem. Okay, so as it is given in the problem 4. Okay, so let us just see. You can see here. Okay, so there are 4 arrangements for the test case 2. Test case 2, see 4 arrangements 1 2 3 4. Okay, so final output 4 we got. Okay, similarly we will test for test case 3. What we should get 1. Okay, so only one arrangement as we solved in code. Okay, so whether our code also returns 1 or not, let us just find out. Okay, so we'll go back to our code. I'm just running the code once again. Run the code. Okay, so then let us enter the third test case. Okay, so copy all the values and paste the values at the command prompt. Okay, so now it is waiting at the command prompt. Just pass all the values in the command prompt. Okay, so just you can see here. Then if you enter 1 we got output 1 we got. Okay, so that means all the test cases public test cases are passed successfully. Okay, so if this is the case, you can submit your code in the online platform of Infosys. Okay, so if it passes all the private test cases also, then you are done with this question. That's how you should solve the questions. So more paperwork if you do and develop the logic on paper. Okay, so writing the code and testing the code, it becomes very easy. Hope you got it. So this problem we have solved. Is the problem? Look at the problem. Okay, so this permutations. Okay, so you at least 10 problems you work out. Okay, so 10 to 15 problems. 10 to 15 problems you work out on a concept called as a permutations. Okay, so from the lead code you solve these problems. Okay, and this is an example for a Euler number. Okay, so generally you'll get a question related to Euler number modified. Actually exactly it is not a. Okay, so Euler number n comma k, there is a function. Okay, so this generates the Euler number. Okay, so which gives the number of permutations for the given number n. Okay, how many permutations are there, that related problem, this also. Okay, but slightly modified. Exactly right. So here I shown a direct approach for this. Okay, but for n value greater than 10 or n value greater than, if you are, what is the constraint here? N value, see here, n value is very large. Okay, so 10 to the power of 3. Okay, so this code for large n values. Okay, so for greater n values, if n value is very greater, okay, so our code takes a lot of time. Okay, so takes time for getting the output here. Okay, so that's why what you need to do to get the basic idea to solve the problem, I have given this logic here. Okay, and it will be very easy to convert this into a DP solution, dynamic programming type solution. You can convert this into solution. Here, what is the advantage with our code? Okay, our code and DP solution. Our code, in our code, what we are doing, we are finding all permutations for n. Okay, so it calculates n factorial permutations, and stores them. Okay, just you can imagine if n is a it is a something like greater than 1,000 or it is 10,000. Okay, so you can imagine n factorial means how many permutations you will get, and all such permutations we need to store. Okay, so if n contains all distinct numbers, okay, so 1,000 factorial uh, tuples. Okay, so you will get, and all those tuples you are storing in a variable called as a permutations variable. Okay, so then you may run out of memory sometimes, memory constraint. Okay, so if you write a DP solution, in DP solution, what you do, you go on constructing the table from the beginning onwards. Okay, so if a value is not present, then you go on adding this to your dynamic program DP table. Okay, so one by one, we'll start from 0 and we go on adding the numbers. In this case, first we add all the tuples, and then we are getting one by one, and we are checking whether it is a valid arrangement or not. But here we go on adding the arrangements one by one here. Okay, so that's why this takes less space. Okay, and will be faster, because if it is already calculated, is available here directly, you can get it from this table and find out. Okay, so that's why DP solution is more efficient compared to this code. Okay, so if you uh, don't understand how to get a solution, okay, so this is the first way of getting a solution for the problem. Okay, so for new users, this is how you can code. Those who are familiar with dynamic programming, they can convert this into DP solution. If you need a DP solution for this problem, okay, so just you can comment in the comment box of this video. Okay, so then I can share the DP solution, or if you really want the DP solution to be explained, okay, you want a video on that, and please comment in the comment box. I'll make a video on DP solution and upload into my YouTube channel. So that's it, friends. So work out problems on lead code, these kind of problems. Okay, so definitely it gives you some confidence when you attend the examination. So thank you one and all. So please subscribe to the channel if you like this video, and if you like the way the problem is solved, and share this video to your friends, those who are writing exam on 8th January. So also click on the bell icon for more updates and notifications related to coding. If you have any problem on coding, okay, so you can just uh, comment in the comment box. Okay, so then I'll prepare video on such topics. If you need any live demonstration of coding of any problem, okay, so if you have previous more Infosys questions, you can just comment all the questions in the comment box. Okay, so I'll discuss the solution.